Thank you, Harry, and thank you, Thomas, for an excellent representation of digitalization. I think it's a perfect lead-in because I want to follow up on a few of the success factors that Thomas mentioned, and that is the industrial Internet of Things demands standardization. Being the leader of a standards organization, I think that makes us cool again. Okay, I can tell from the reaction, Ted, you never were cool, but at least it makes us relevant in the age of industrial Internet of Things, and it gives us a lot to do. There's a lot to do because the standardization goes well beyond how devices communicate to each other and even how they communicate to hosts. Standardization is required at the integration level, and it's required at the data level. Big data in our industry can be a cost. If we have a bunch of big data unorganized, it can become a mess and a liability. Big data organized in terms of structure and models and context is how you can turn that data into intelligence and leverage it across the enterprise. So that's the key point that I think we want to talk about today. I'm excited to be here at ARC. I'm excited to have our partners OPC, because this is the key to turning this data into value from field devices in the context of the industrial Internet of Things. And we're going to talk a lot about our relationship with OPC, which we've taken to another level, a higher level, in some ways a lower level, but that doesn't sound so good. But we're taking it to a higher level to leverage OPC's expertise in owning the world in terms of data structures, and apply FieldComm Group's domain expertise in process automation to do just that, to build out data models that are valuable and turn that data into information. So that's mainly what I want to talk to you about today. And with that in mind, if you read your ARC emails, you probably got a few, but one of them, we had a press release on Monday and announced this joint cooperation between OPC and FieldComm Group, and the intent of that is really to build a process automation information model leveraging the data structures that are already in place in OPC UA. Basically, at the lowest level, we need a, sorry about that, okay, so at the lowest level, we need to, in the cloud or in the context of the Internet of Things, we need to represent the devices as a digital twin, as a virtual device with all the data. That requires the data and a model to do that. OPC UA and FDI, which we're going to talk a little bit more about, share the same information model. OPC UA device information model is shared and built into FDI, if you will. What we're trying to do with this cooperation is we're going to build a level of detail below that. We're going to build a device information model more specific to process automation devices that really characterizes all the parameters of different device classes, and that way puts all the like data in context, regardless of the supplier, regardless of the protocol, so users can worry less about these interoperability issues and rely on a standard process automation-oriented device information model, a drill down from the information model that's already an international standard. So this is the nature of our work with OPC UA. Tom's going to talk about that a little more in depth. And the first deliverables of this through FieldComm Group working groups and our collaborative venues will be to deliver this in the spring of 2019, and that's what you'll see in your press release. So with all this focus on information models and data and bringing this data in the context of the industrial Internet of Things over to the IT side, I get the question a lot, are the protocols becoming obsolete? I'm seeing protocols like this, and not necessarily protocols like that. So I get this question a lot. And it's really a fair question, and it's a bit self-inflicted, because some of the very strategies and projects that we're undertaking at FieldComm Group really are designed to make the protocols invisible. So are we really losing sight and obsoleting the protocols that are traditionally process automation with protocols that are traditionally IT. Some would say yes, but not so fast. I would say that even though we're trying to allow the users to worry less about the protocols are still an underlying part, and FDI, which we'll talk about in a little bit more, helps users manage the protocols, but we firmly believe the protocols are here to stay, and that the protocols are a real core of a conduit to get the data to connect to. The Internet of Things relies on a lot of data and a lot of structures and a lot of standards, but you've got to get to the data first. And there's a lot of use cases out there in your typical automation plant, and the different protocols with 20 years of experience and security and reliability built in solve those different use cases. So they're very robust ways of being the fundamental conduit to getting the data in to the systems that need it. I guess the second point I would make is there's going to be many protocols required. The Internet of Things is not one protocol. There will be many protocols out there. And last but not least, we talk to users time and time again, and users tell us one common thing. In the industrial Internet of Things, we're not ripping out all our field devices. And I believe that a lot of these new architectures recognize that and finding ways to create standards around how to work with the installed protocols and get that and leverage that data and get it where it's needed. So that's our slightly biased opinion, but we think the protocols are here to stay. So Harry introduced FieldComm Group. Of course, we, in a lot of cases, we're not that known of a name. We're only a few years old as a corporation, but the inception was what you might refer to as a merger between Hart Communication Foundation and Fieldbus Foundation. That may have been the initial step. It wasn't the intent. The intent was to create a venue and an environment for digitalization and collaboration, and that's kind of where we've taken it, and FDI has really been the first major step to that. FDI, which you'll hear a little bit more about, is an integration standard that brings these protocols together, which really changes the whole tone of foundations in the sense that, you know, what we once referred to as Fieldbus Wars, we now refer to as our collaboration partners, and we're all working together to try to create some standards in the industry. We still support and enhance these core technologies. Hart is, of course, the most widely adopted technology, and in the context of industrial Internet of Things is gaining momentum. Hart is sometimes has a reputation of maybe not meeting the full capabilities of an Internet of Things world. But with technologies such as Hart IP, where you ramp up the speed of Hart, that takes away a lot of the concerns. So Hart over Hart IP is a great solution for getting data into the Internet of Things. And the other technology that's a derivation of Hart is Wireless Hart. Wireless Hart, of course, is a pure digital technology and is rapidly growing in terms of the base and the use, and I can't imagine an Internet of Things without wireless. So I think we'll continue to see that flourish, and we'll continue to leverage the tremendous install base of Hart in ways to ramp the speed up. Foundation Fieldbus is also, as you know, our pure digital technology, and this technology is well ingrained in many plants, standardized, and plants have created the internal structure to support it. It's NOC, if you will, that has limited adoption, has been complexity, and the efforts that we're going through at FieldComm Group between partnering with our users, which I'll talk about in a moment, as well as projects underway, are usability efforts. So we see that as a solid technology that that serves many use cases, and a lot of plants are expanding in it and using it, and it certainly provides a pure digital interface. And then bringing them all together, of course, is FDI, which is not a protocol. FDI is a technology to, in a protocol independent way, to bring various protocols into a host in a common and standardized way. I would be remiss of my duties if I didn't throw a cheap plug in here for registering your products. But I think in the context of more and more standards and in the nature that we all want openness, that really requires more conformance to the standards. If you want a world of openness and you're not showing some way of conforming to the standards, you can create a real mess once again. So right now we've had many certifications over the years, system-wide on Foundation Field Bus. Of course, lots of HART products registered out there, and we've been working very hard to put the infrastructure in place for FDI registration. So we have everything created for that. We have a device repository where we'll be collecting and standardizing the consumption of device packages. We have host and device test procedures in place, and we expect many registrations for FDI products to be coming out in 2018. We have lots of submittals, I won't say lots of submittals, but a building number of submittals in for registration, and I expect those to be popping out. So if you're an end user in the audience and you want to future-proof your plant, I would ask my supplier that my next host be FDI registered, or ask them if it will be FDI registered. And this will drive the new integration standard for bringing data into your plant. It's also a widely adopted standard, and it's endorsed by Nomura and other companies that, or other organizations building, you know, the proposed architecture for Internet of Things. So look for FDI coming soon, I guess is my message. So information models is what we're going to talk a lot more about today. I'm going to let Tom drill into a lot of the details, but you know, what exactly is an information model? It's really, you know, just a structure and a mechanism to organize the data around common parameters and drive value out of it. And it really makes sense out of this. It'll take information like this and bring it into context so that it can be mapped as a digital twin with a DCS company. Maybe the data is used and compared in context enterprise-wide or in the cloud for analytics, maybe from mobile devices, or even for control. So the information model can help represent all these aspects of a process automation device through a variety of systems to enable these functions to occur. But the parting message on the protocols, it all starts with the data, and you've got to find a way to connect to the data. So integrating these standards from the field device level to the host and integration level to the cloud is the goal that we're out here to achieve. So it's really complex. As I've said, there are many protocols to deal with. There's lots of supplier variances. FDI is just emerging on the market, but it's really hard to bring all this data in from different sources and get it in context. We're working on that, and what we do is we recognize a plan of the year. Really for a couple of reasons. These folks have done this work, as complex as it may be, and they've found a way, in a real innovative way, to use it and turn it into value. And there's nothing more that will lead the market and drive other folks to do that than the proof of value. So the other benefit to us is we get a lot of technology ideas, and we get our roadmap set by the complexity users have to bring in this data. Things like FDI and building a process automation device information model will all make things that they've done that are a little laborious much easier in the future. So the plan of the year is a great award to both lead others as well as lead us in terms of what we need to do to make it easier for them to realize this value. And we've recognized the plan of the year for a long time now, since 2002. It's a big deal every year. We get lots of nominations. We've had one two-time winner, the MOL refinery, and each of these, actually BP is another one, but each of these operations have turned the data that they get from field devices into tangible value. These stories are all on our internet if you want to read the value cases and the messages and the stories that they have. I want to encourage you also, if you are a user out there and you have done the same in an innovative way, are turning this data into value, we'd love to hear from you, and we'd love to have your nomination for Plan of the Year 2018. For 2017, I wanted to take this opportunity to announce the Plan of the Year winner, and this is the Shell Prelude plant, which is a floating liquid natural gas refinery, if you will, out at sea, and it's quite an engineering marvel. In addition to the technology from FieldComm Group, it's quite an engineering marvel. So it makes a great representation for our Plant of the Year, and I think as engineers, we can all be kind of amazed at some of the things they're doing. It's really big. 4 or 5 football fields, depending on what you call a football field. I understand is why there's a deviation. I think they might have thought a soccer field, but we know it's a football field. It's miles and miles out in the middle of nowhere, has lots and lots of complexity to it, and the storage is equal to 175 Olympic pools. So it's just a massive behemoth project with, and we'll talk a little bit more about the devices and technology behind it. But first I wanted to showcase this a little because it's something you might be interested in and quite an amazing facility.
In a global engineering project of extraordinary scale, destined for gas fields previously thought too challenging, Shell is building a floating facility that will liquefy natural gas at sea. Piece by piece, 14 gas plant modules have been built on a quayside, then carefully lifted onto a giant hull. Now the last module is ready for installation, and Prelude is taking shape.
Getting the last module, that's a real accomplishment by everybody, and from now on progress won't be that visible, but on the other hand, of course, there's a lot of work to do still.
There are 3,000 piping connections to make, 450 kilometers of cabling to pull. So now that the forest of yellow steel is now going to get connected together, so it's one piece.
This cargo tank, which is for LNG, is 39,000 cubic meters. It's difficult to imagine.
We're in the liquefaction module, and we're at the very heart of the liquefaction process with this refrigerant loop being assembled now. For top sides only, we got 60,000 pair of flanges to make. Everyone has to be done right.
We're at the front of Dry Dock 1 here, where our 7 MLAs, marine loading arms, have been for the last few months. As you can see, they're all assembled, ready to be lifted, ready for FLNG. So hopefully we'll get to see that in the next few days.
When we see the last module coming on the deck, then now the real work will start.
Now, if you were climbing Mount Everest, I think we are well past base camp, but there's still quite a long way to go. And of course, as you go, it gets narrower and narrower.
Tell you what, I'm going to give another analogy. I'm going to talk about Wales winning the Rugby World Cup. We're just getting ready for the semi-final.
It's a little commercial by Shell there, I guess. At any rate, quite an exciting project. We're honored to have this Shell facility as our plan of the year, and you'll be seeing more coming out on that and more detail in terms of how they're capturing the value. They use most of our technologies, over 8,000 foundation field bus devices, 4,500 HART devices, hundreds of wireless HART devices. So really quite a complex system, and we're partnering and working with them to try to make these things easier and learn from what they've done. One of the things that they've done that a lot of our, as we try to make it easier, is they've created an idea of device templates to help in the commissioning, the lessons that we learn and the structure that we get. We're working on ways how we can share that with others, and you know, make some of the things that were complex easier. And that's kind of the message of what we get out of these plan of the year opportunities. So making it easier, we talked about standards all up and down the level, and that's what we want to talk a little bit more about here in our work with OPC-UA and our work with FDI to take the core conduits of this data and standardize it up the way to the cloud and back down again. As the cloud seems to hover in my mind, data is going up to the cloud, but now you know it can come back down into the enterprise and to the edge devices. And when we talk about standardizing data models, we're really talking about standardizing a digital twin wherever that may reside. So FDI is the key to that. The first step and one of the keys is a device package. The device package essentially would bring multiple protocols into a host, and where it is in the host with embedded OPC-UA model facet in the device information model, then the data is very easily transmitted to the cloud. As we drill down into that process automation device information model that we make, it becomes even easier and easier in the context of our domain expertise. So I want to give you just a little bit on FDI. It's coming soon. You'll see some registered products on the market, and we're conducting training, and we'll get you set up, whether you're a host supplier or a manufacturer of devices or a user that's interested that wants to future-proof your plant. Please contact us or our website for more information. And I just wanted to share a little introductory video with you.
What is FDI? FDI is an internationally standardized solution for process automation, device, and systems integration that dramatically simplifies software installation and maintenance, as well as communication between enterprise-level systems and technologies on plant floor. Before FDI, individual devices often came with hundreds of files to address different systems, configurations, and interfaces. With FDI, a single device now uses one file to provide data and process values to all systems. An FDI system is made up of two parts, an FDI device package and a host system. The FDI device package is a standardized container of all files necessary to describe a field device to a system and a person, including the device description, user interface, and device documents such as wiring diagrams, manuals, certificates, etc. All of these elements are packaged together in a digitally signed FDI device package. An FDI host system in process control can be a DCS, PLC, an asset management application, or even a configuration tool. FDI host systems are made up of an FDI client and an FDI server. FDI hosts may also provide an OPC UA interface to field protocol communication servers, thus allowing disparate machines and systems to communicate. The communication server is the key element enabling FDI to be broadly adopted into the IIoT and Industry 4.0 initiatives. In particular, the communication server enables local or cloud-based OPC UA connections, which simplifies integration with existing IT infrastructures. FDI and OPC UA deliver access to plant data from across the globe, allowing corporate offices and subject matter experts to optimize assets and stay ahead of the competition, all while providing built-in data security. FDI and OPC UA enable the digital transformation of process plants to work more efficiently and effectively with fewer resources and tighter constraints.
Well, thank you for that. And one parting note I'd like to say is how is the value all delivered to the industry in terms of what we want to all achieve, and that's digitalization and getting the value from that. And for us, it's all about collaboration. If I leave you with nothing else, I just want you to understand that these are not the old field buses. The FieldComm group has created a venue of collaboration and working together, starting with FDI, where you're working with multiple protocols. This kind of kicks off the spirit of collaboration. We work closely with OPC, Profi Bus, FDT, organizations in terms of managing the FDI integration spec. We work very closely with Profibus as a partner to launch and support FDI to the market. So they have become a very close partner with us. And then many others, as it's an all-inclusive technology, the technology works as fantastic with ISA 100 and as it does with Wireless Heart. We're collaborating with all of the protocols and working closely together. When we get up to the data modeling, now we're shifting gears and really strengthening our work with OPC UA to take that data from field devices, get it through the integration, and get it all standardized in a process automation device model.